And just to give you an idea of how the bearings should be, so this is the new turbo. If I pick it up and I rotate it, alright, see how that first fan stack will move just by moving the pump. Let's try that. With the old pump. Stuck. Okay, on to mounting the new turbo. So this is the new turbo mounted, and here's where the new turbo flange mounts the vacuum chamber. And we have here space of around 40 thousandths of an inch. So, and the other thing is that the outside diameter of the turbo is a little bit smaller than the vacuum flange, the base of the vacuum flange. So the question is this a slightly thicker gasket, or has some part of the installation gone wrong? Yeah, so I'm going to check into this. Alright, remember that 40 thousandths gap? Alright, it's not there anymore. It used to be right here. That's because that cute little flat aluminum colored seal that I washed and wiped with ethanol and put back in the pump, that's actually the tapered seal for the old pump. So once I took the pump off again, took out that seal, and I was able to put this in here, and now that gap has gone away. Of course, we'll have to find out if the pump works. Yeah, now that I've modified things. In reading various things on the Pfeiffer Vacuum website, there are some recommendations. One is that if the turbo is not going to be used for 2 years or longer, that before subsequent use then, that the bearings be replaced. So it doesn't seem like I should get the bearings replaced right now. The other thing is that, so this is the top without that conical sealing flange, and I thought I'd take a look as to what the orientation is. I'm pretty sure that it's cone up in this configuration, but let's just check. So let me zoom in a little bit more. Alright. Alright, so this is with the cone up, and this is with the cone down. So I'm thinking cone up is the way to go. And of course, this is not a Pfeiffer pump, but labeled. Right. And let me, I need to get one more thing, and that's the 4-pump connection off of the old turbo. On the old pump, this is where the connection is to the 4 pump, the rough pump, and so this can be nudged out. Alright, and then there's an O-ring. Now, alright, we have this, so this came out like that. And then here's the O-ring. Alright, so we'll put the cap from the new pump on here, and we'll clean this up with some ethanol, make sure it's clean, and reuse this. On the new pump, here's the cover off the foreline. So now we have a metal centering ring and also an O-ring, and it attaches to this flange. Let's see, alright, this flange here, and then the yoke is going to hold the flange against the turbo. I guess we'll see how this improved centering device works as compared to, this was the old one, so we have the pump, the O-ring, and then this fit in, this was the centering device, okay, and then the O-ring on top of there, okay, and then the cap, right, and then the yoke. Let me put the yoke on. Yeah, the yoke is going to hold this cap on. Alright, I've just put the 3 bolts on here, finger tight. This pump's going to go in storage. So let me just give it, maybe a half turn to snug things up. Okay. So now the fun's going to be with the new pump, attaching the foreline connector to the turbo. That is the setup. So here's the foreline tubing. There's that newer connector with the metal centering tube. And I guess we'll find out how well it does. Alright, so 2/3 of the screws are in. Alright, just finger tight. Here we have the yoke, foreline tubing, connection point, foreline port. The tricky thing is this last screw back here. Make sure you have some aluminum foil or something, so in case you drop the screw that you can retrieve it. And one thing to be aware of is as you can open this part of the panel, alright, not that much, but it does give you some extra access. Ideally, if we could get rid of this, that would be nice, but we can't do that. Right. So it's tricky, but it's only one screw. It's definitely tricky getting that last 3mm hex screw in. So use longer tweezers and the 3mm ball end hex wrench, and eventually you kind of get you get to this last screw here. Right? And so then you have to evenly tighten, as best as a person can do, snug up that O-ring so there aren't any leaks. One trick to get this short 3mm hex screw in there is to hold this tubing out of the way with the 5mm ball driver hex wrench. It's only one screw. Another trick to hold that red and Teflon tubing back so you can get your little 3mm hex wrench to that farmost inside bolt is to use the handle and drive it in. You just kind of wedge the stuff in, and then you can release it when you're done. When the yoke is nice and tight. Another new pump installation question is whether or not on this 4-pump connection, see how there's essentially no gap between the flange and the body, between the flange and the body here. And that's because this has the metal centering and one O-ring. So I'll have to find out whether or not this is sufficient or whether I have to take out the plastic 4-pump centering ring and O-ring configuration from the old pump and swap it. So I guess I'll find out tomorrow or the next day when I can talk to a human being. So here we have the new turbo mounted, but we have to exchange the 4-pump hardware connection for the old setup, and so that means getting to these two and unfortunately that third 3mm screw. Alright, so let's see if we can have some tricks to get to it. Since the back screw is the most difficult on this yoke, I am going to use this. This is a offset bit driver, and you can have a 3mm ball hex bit, and then that can fit in there at user-friendly angles, and you can loosen it this way. Okay, so what I do is I hold the back down with one, and then this is ratcheting. Alright. Not bad. Okay, let me go to a front one. Reaction, alright. And let's try that top one. Alright, well, not enough swing room. Well, yeah, just enough. Okay, so that's one trick. Offset bit driver with a 3mm bit. Alright. Now, since the hex on this is 1/4 inch for the bit, we can also use a 1/4 inch ratcheting end wrench. So this is even smaller, needs even less swing room, so you can compare. Offset, but this is magnetic. This has a this, the bit will go right through, so you have to hold it. And I suppose another trick is to actually take the cover back off. Now we're going up. On my vacation for 2 weeks, so I put the cover back on loosely. Alright, this gives us some more swing room to work on those 3mm screws. Alright, this screw and that screw are off, yoke has been pulled back, and so now we can disconnect that. Alright, and now the question is, this is because I'm lazy and I don't want to take the new pump off again, but so what I'm going to do is pull this centering device and swap it out for the old, and then see what happens. Alright, this is the centering ring for the 4-pump vacuum that came with the new pump, and this is off of the old assembly. Alright, so we're going to put this back in the pump. You also need to move the 3mm screws from the old pump to the new pump. And I'm going to wipe the O-ring with some ethanol before inserting. Alright, so we have old centering system, one screw here. Let's put another one in here. Okay, and let's get the yoke and the rest of the stuff on here. I work the yoke onto the bottom 2 screws first, and then this top screw is going to be last, and then I'll try and tighten things evenly. Okay, so now I've used the offset bit driver, and I've tightened it gently but firmly. I'll tell you, this ratcheting offset bit driver with the ball 3mm hex bit, definitely the tool to have for this. So, let me show you the tools that I used. Alright, so we have our 1/4" ratcheting open end combination wrench. That's to drive the bit if necessary, and if it's small restricted space. Our offset insert bit driver, and this one, it's magnetic, and so we either have 1/4" or 5/16. And then of course our 3mm longer ball ended hex wrench. Those are the drivers I used for swapping out the 4-pump vacuum connection. Next we put our connectors on, and then we're going to take the aluminum foil to catch any small dinky stuff from falling down into the fan bay and never being able to get it. We remove that. And now it's time to start buttoning up the mass spec, putting things back together. Alright, one of the things here is, originally it was just a tab from here. There's a grounding tab Now what I've done is I've added a second one here, and given the clearance, you have to be careful that this lines up with this, and so let's do that. There are 7 screws left. Alright, one's going to go here, and 6 are going in the back area there. So let's get the covers on and start attaching things. And while we're at it, we might as well also clean the fan filters. So, right side is on, or left side if you're at the back of the instrument facing forward. Now for the other side. So the cover has been placed on, alright, and the trick here is to make sure that this edge sits on this part of the on this other cover. Okay? And no screws have been tightened yet. There are your typical longer screws here, and then there are going to be 4 screws up to the panel in the back, and there's this guy here which somehow I've lost. And you put the source housing back on for the electrospray. Alright, in the back we still have the 4 pump to hook up to here, and then this panel. Alright, you can see it's also grounded. Instrument has a Faraday cage. And this has to be attached before we can start pumping things. So let me do that. There's a cutout for the connection to the 4 pump. Alright, put in the 6 screws, just finger tight first before you start tightening them down with a hex driver. Once these are tight, then we'll put on we'll do the connection to the 4 pump. And to save time, I typically note on the connection, I've noted with a Sharpie 7mm, so it'll save you time when I come to check the connection after pumping down. And this might out of focus here. Next, it's a matter of plugging all the cables, power cables, communication cables back into their proper location. It is a time to also check. So this is the back of the rough pump, 4 pump, and one thing to decrease the heat load on that pump is to get some inexpensive fans. They'll last a few years, and then you just throw them away and you get another one. And so if you have 2, then when one dies, you go out to the store, you get another one, or you have a couple, you buy a couple when they go on sale. Anyway, it's this is the front of the thing, and so you have a nice breeze through here, helps decrease the heat load on that 4 pump. Alright, so in the initial powering on, we have just the main power switch on, and we have its still the electronics in the service mode. The rough pump is running. I don't know if you can hear it. It's very quiet. In this setup, I have a voltage conditioner. So that is on. Otherwise, the rough pump wouldn't work. And I think I can hear the turbo on. It's hard to say. And with the electronics in the off position, no LEDs are lit. If I place my ear against the chassis side cabinet here, I can hear the turbo spinning, or at least. So I'm going to let it pump down now for a good 10-15 minutes before putting the electronics on. Roughly half an hour after starting the pump, the electronics are put into the operating mode. So that's the switch down here, side panel, next to the main one. And the status is LED is amber. And if we go to the screen, we will see that we have a high vacuum non-compliant condition. Considering that the turbo's been spinning less than an hour, I'm not going to worry about it. I'm going to let it spin overnight. It's the source turbo spinning at 100%. The high vacuum turbo is spinning at 100%. Right now the ultra high vacuum is at 6.9 e to minus 8. Alright. And 15 minutes ago it was 8.3 e to the minus 8. So it is pumping down. So roughly an hour and a half after turning the power onto the pumping system from absolute cold start, we're at around 5.03 times 10 to the minus 8 millibar for the ultra high vacuum. So we'll give it overnight pumping out and see where it is. And 20 hours after the initial startup of the turbo pump, the ultra high vacuum is in the mid 10 to the minus 9 millibar range. So I'm going to let it go for 24 hours and then I'm going to enter bakeout. Before I have it go into bakeout for a couple of days, what I'm going to do is have it pump the remainder of this first day and have it pump some nitrogen. So I've turned my standby ESI tune file in order to get some nitrogen, sweet gas going, and that, if anything, has only helped the rough pump vacuum, and then the high vacuum is also okay. I think with bakeout, this has dropped to a reasonable level. So I guess we'll try the experiment. So we'll let it pump a few hours at the nitrogen on and then enter bakeout. Alright, after pumping for a couple of hours with some nitrogen in the source, the fork vacuum has dropped and the ultra high vacuum is about the same. So now we're going to send it into bakeout and we'll see what happens after, say, 24 hours of bakeout. After about a minute or so, the ultra-high vacuum has gone up into the 10 to the minus 8 millibar range, and of course that switches the orange to red, little indicator, but we know why it's in the red. Nice thing about bakeout is that we'll have a graph of the temperature, pressure, analyzer temperature, vacuum pressure, and we'll see what happens. After 6 minutes, it's gone up. Okay, so let's see if I can get this. It's up 1.34, 10 to the minus 8 as far as vacuum. Analyzer temp is approaching 40 C. So we'll see how bakeout proceeds. Okay, just about 2 hours into the bakeout, and pressure is starting to drop. Pressure sort of maximized out in bakeout after about half an hour, and almost at 10 to the minus 7, and subsequently it's been going down. Temperature right now is up at about 115 C on the analyzer. Present temperature at about 1 3/4 and is 4.45 e to the minus 8 millitorr. After 20 hours into bakeout, pressure is 8.6, 10 to the minus 9 millibar, and it's still heating. So this is the K curve here. Is the pressure. So after a 21-hour bakeout and 2 hours of cool down, we have green LEDs for vacuum and status. Good. Okay, and this is our vacuum bakeout graph. And so now the ultra-high vacuum is down to 1.1 times 10 to the minus 9 millibar. Core vacuum is at 2.27 millibar. So that's good. And you can see, alright, this is the point where the heating stopped. So, after 24 hours of bakeout and cool down, followed by a weekend of just pumping at standby conditions, we have a vacuum of, and we'll move over here and take a look. Roughly 7 e to the minus 10 millibar for the high vacuum and 1.7 millibar for the core vacuum. And in this particular tune file, we have a little bit of sheath gas flow going in as well as some sweep gas. So the theory being that it's better to have the instrument pumping clean nitrogen bleed off as compared to possible dirty room air. So, looks like our replacing of the main turbo and servicing of the source turbo worked. Let me go over what I consider an absolute must for those 5mm hex socket mounting bolts, the 4 of them that mount the turbo to the manifold. Right? So you have a typical 3/8 inch ratchet, right? Another variety, right? And you have an extension, right? And you have a socket, right? Fits on here. Alright, so instead of having a socket, you get a hex adapter, a hex bit adapter. So this is the 5mm hex, and this is the end that fits onto the socket wrench. Right? And so now you can tighten, loosen, alright, if you could get to it. So you need an extension bar, and that's what this is. Alright, so you get you get your 5mm hex to socket. You get a nice long extension bar. You can put that onto your wrench, your ratcheting wrench. Now you can tighten or loosen. And the nice thing is, well, gee, this doesn't have to be just a ratcheting wrench. It can be a torque wrench. And so now you know how much force you're applying when you're tightening the mounting screws. That way you can tighten them more or less evenly.